Unit 2, the memory system. Now these are the topics we will study under the Unit 2. Now the main objectives of this Unit 2 is to study the memory circuits and organization of main memory, cache memory concept which increases the speed of the system, virtual memory mechanism which increases the apparent size of the main memory, and along with these memories we are going to study the secondary storage devices like magnetic disk, optical discs, and magnetic tapes. So these are the different types of memories we are going to study: main memory, cache memory, virtual memory, and secondary memory. Now, introduction of the memories. Now, the execution speed of program is highly dependent on the speed of the instruction, and data can be transferred between the processor and the memory. Now, if this is the processor and this is the memory, so how quickly the data transfer takes place between memory and the processor? Now, this gives the system speed. So nowadays what we want high speed and large memory and inexpensive. So cost should be less. Now it is impossible to meet all these three requirements simultaneously. If the speed and size is increasing means, then definitely cost also increases. To solve this problem, the improve the apparent speed and size of the memory by keeping the cost reasonable. Now we need to introduce few memories like a cache memory, which will increase the speed of the system, and a virtual memory, which will increase the apparent size of the memory. Now, along with, we are going to study the secondary storage devices. Now, some basic concepts. Now, already you know that 1 bit is equal to 0 or 1, logic 0 or logic 1. Now, nibble, N-I-B-B-L-E, nibble is equal to 4 bits, group of 4 bits. Now, 1 byte is equal to 8 bits. Now, before going to study how the processor read and write the data, now we will try to analyze the relation between the address lines to the memory. Now, memory size depends on the address line, 2 to the power of address lines. Now, if it is having the k bit address lines, then the memory size is equal to 2 to the power of k address location. Now, if my system is having 16 bit, then it is having 2 to the power of 16, that is nothing but a 64 kilobyte memory locations. If my system is having the 32 bit, then 2 to the power of 32 is equal to 4 gigabyte address locations. If my system is having the 40 bit address lines, then 2 to the power of 40 is equal to 1 terabyte memory locations. 1 kilo is equal to 2 to the power of 10. 2 to the power of 10. Now here 64 kilo, if I try to convert into the address line, 64 kilo. So 64 means how can I write? 2 to the power of 6 is nothing but a 64. 2 to the power of 1, 2 to the power of 2 is 4, 2 to the power of 3 is 8, 2 to the power of 4 is 16, 2 to the power of 5 is 32, 2 to the power of 6 is 64. Kilo means what? 2 to the power of 10. So total how many address lines are there? 16 address lines. Now, similarly, 4 giga. Now, kilo means 2 to the power of 10. Mega means what? 2 to the power of 20. Giga means 2 to the power of 30. And tera is equal to 2 to the power of 40. Now here also you can see that n bit data bus. Now from the processor to the memory, there is one address bus, data bus, and control lines. Now if address bus is having k bits means what? it is having 2 to the power of k address location. Now this is memory is divided into these locations. Now how many locations are there? 2 to the power of kilo locations are there. Now if n bit data bus means what? In each location n bits are stored. Now in modern computers, byte addressable. Modern computers are byte addressable means what? In each location, 8 bits can be stored. 8 bits can be stored. Now how the processor is reading the data and writing the data, we will see. Now this is MAR. Processor is having two registers: MAR memory address register, MDR memory data register. By using these two registers, always the processor is communicating with the memory. If the processor want to read the data from one location, now from whichever location processor want to read, that location address will be placed on the address bus, and read oblique write bar signal become 1. Processor makes this bit is equal to 1. Thereby what? So processor read the data. Now in response to this, now the memory will place the data from that location onto the data bus. And also it will insert the MFC signal. MFC means memory function completed. So after receiving the MFC signal, now whatever the data on the data bus will be loaded onto the MDR. Like this processor is reading the data. Now if the processor want to write the data into the location, now in whichever the location processor want to write, that the location address is placed on the address bus, and whatever the data should be loaded, that data will be placed on the data bus, and read oblique write bar will be become 0. Processor plays the 0 on this line. So thereby it is writing the data into that location. Now whatever the data is available on the data bus will be loaded onto the location. This is how the processor is reading the data from the memory and writing the data into the memory. Now in this case, I have taken the 8 byte addressable means what? In each location, processor can store only 8 bits. Now if the processor is 16 bit, then it will send the 16-bit data to the memory. But in each location, it will store only 8 bits. Then processor plays the address of the starting address. Means this 16 bits can be divided into what? 8 bit lower order and 8 bit higher order. So this is the lower order, lower byte, and this is the higher byte. Now it will place the address of the starting address, and the lower byte will be stored into that address location, and after that automatically the address will be incremented, and in the next consecutive memory location the higher byte will be stored. Now 2 bytes are stored in the consecutive memory location, but only one address is placed on the address bus. If the processor want to store the 32 bit, if the processor is 32 bit processor and it wanted to store the data into the byte addressable memory, then this 32 bits will be divided into 8 bits, 8 bits, 8 bit like that, 8 bits. But processor will place the only starting address of these four bits will be stored in the consecutive 4 memory locations. But now here the processor will place the address of the starting location. Now after initiating the starting location, lower byte will be stored into this location, and the address will be incremented. Next 8 bit will be stored, address will be incremented, next 8 bit will be stored and address will be incremented, and the last higher order 8 bits will be stored. Like that, for the 4 consecutive memory location, processor is placing only the starting address. So now this type of transfer is called the block transfer. Block transfer. Now in this only the starting address is placed on the address bus. Automatically the next consecutive locations are selected and the remaining data will be stored. Now The speed of memory unit is the time that elapses between the initiation of the operation and the completion of that operation. Now, for example, the time between the read and MFC signal. This is referred to as memory access time. Now, what is memory access time means? The time between the read and MFC signal. Now, the next term is memory cycle time. Memory cycle time is the minimum time delay required between the initiation of two successive memory operations. For example, the time between two successive read operations. Always the memory cycle time is slightly larger than the memory access time. Now, these are the two terms which we use to measure the speed of the memory units. Now, the important design issues to provide the computer system with as large and fast to increase the memory and to increase the speed that can be possible by introducing the cache memories and virtual memory concept. Now, these we are going to study in detail in the forward lectures.